Okay. Listen. So the question is, give evidence for cyclic structure of glucose. Answer is, does not reduce or give shift test. It's not answering for shift test. And second point, it's not gives hydrogen sulfide as an addition product with sodium hydrogen sulfide. And then third one is does not react with NH2OH, hydroxyl amine. That is the evidence what we have to prove that presence of C double bond O, right? So these are the points you must explain it. Okay. Does not react with hydroxylamine, indicating the absence of aldehydes. And see, what are the two different crystalline forms of glucose? One is alpha form, right? The other one is beta form. Alpha form, beta form, right? Okay. Okay. And say it forming a hemi acetal compound. When it undergo nucleophilic addition reactions, it forming hemiacetal. Okay. Now see the cyclic structure. Now see the cyclic structure of glucose. Listen ma'am. Actually, here what we had that this is the structure of glucose, right? The middle one is structure of glucose. First one is aldehydic carbon, then last one is primary alcohol. So between that we have 4 secondary alcohols. Now see this oxygen expand to make a bond with this hydrogen, right? This oxygen taking this one. Actually because of that here a new bond is formed. It's called OH, right? This oxygen combined with hydrogen, and then on the 5th carbon we have free oxygen. That free oxygen mentioned right hand side. This OH I have written. This bond is called as glycosidic linkage. Glycosidic linkage. Right? Actually here it is not glycosidic linkage. Here it is not glycosidic linkage. Listen, 1 minute ma, wait ma. Why I mentioned that glycosidic linkage is formed between this glucose and fructose. Glucose and fructose, that only called as glycosidic. They are also from C1 to C5 carbon. I thought you remember that. That's why I said that. Actually, this is not glycosidic. This is oxygen bridge only. This is oxygen bridge. That's not needed for us. Actually, we are proving that cyclic structure. That's all. And actually, this is not important for you. See, what are called anomer? This is important. What are called anomers? 2 more questions. Anomers are the isomers which differ the position of OH at the first carbon atom. Anomers are the isomers which differ by the position of OH group. See, right, these are anomers. OH group at the first position, first carbon. See, this one you can take it. This is the first carbon, right? Listen, this one is the first carbon. In first carbon, position of OH on the right hand side. Here, position of OH at the first carbon is left hand side. Now, these two structures are called anomers. Anomers are the isomers which differ by the position of OH at first carbon or C1 carbon atom. Terminal means sixth position also terminal only. At the C1 carbon atom or first carbon atom. This is a 2-mark question. What are called anomers? Okay. Then here, how we are representing the cyclic structure of glucose. We are comparing with pyrene. You must know the structure of pyrene. 6-membered ring. See, this one you can draw like this also. This also right. And you can draw by this method also right. This also correct only. This is vertical position, this one is horizontal position. Now see that how we are converting that linear structure to cyclic structures. For this more colors, any more colors? Only these colors are. Okay. See how we are converting the structure of glucose to cyclic structure. See, if you look the structure of glucose, at the bottom we have, what is the name of this structure, which is resemble with glyceraldehyde. Okay. So bottom CH2OH. You should be very clear with the structure of glucose. Right side OH, then again right side OH, then left side OH. So 1, 2, 3, 4. Fifth carbon right side OH. Am I right? Now see, what about sixth carbon? 1, 2, 3, 4, 5. CHO. That only converted as OH. Because this hydrogen moves to there, right? Now a bond is formed between the first carbon and the fifth carbon. Correct? This oxygen, listen, this oxygen only they mentioned here. First carbon, this is first carbon. Right hand side OH, that I brought to bottom. Then second also OH, bottom. Then hydrogen, bottom. Then OH, bottom. Then CH2OH at the top. சொல்றது புரிஞ்சா? See, first that benzene structure, oxygen, then actually you can draw the bonds, right? OH, 2OH at the bottom, then H, OH, then again H. This one is CH2OH. Very simple. Right? This one is OH. See, in this structure, at the C1 carbon atom, OH is on the right hand side. That is alpha D. When you place it left hand side, then it will go to top. That is beta D. Very simple structures. Draw the alpha D and beta D structure of glucose. Now can you practice it? Practice the two structures.